Okay, Mr. McKenzie asked John, Cole, Evan, and Daniel to pick a number from 1 to 10. What is the probability that they pick the same number? Okay, so we have multiple events happening. So we have 4 different people. So each person would be considered an event. Okay, so my questions for you, is this an and or an or question? Is it and or or? It's and. So John picks the number, and Cole, and Evan, and Daniel. They all pick the same number, okay? It's not Daniel picks one or the other guy picks it, or no, they all do it together, so it's an and. So what if it's an and, what operation are we going to be doing? What operation will we be doing if it's and? So when it's an or, we do one operation. If it's and, we do a different one. Yeah? Multiplying. So we're going to be multiplying probabilities together. Okay, so let's look at John first. Okay? So he's going to pick a number between 1 and 10. Okay, so how many options? Well, not how many options. So he's going to pick one number. So he's going to pick one number out of 10. So one number is the number of times, and the total number is 10. Okay, so one pick out of 10 trials, or 10 outcomes. Okay, then it's going to be times. Cole isn't going to pick a number out of 10, but we want it to be the same one. Okay, so it's going to be the same answer, 1 out of 10. Since we could repeat the same number, we want them to repeat, it doesn't change the denominator. It's still, the denominator still stays as 10. Okay, so same thing with Evan, so 1 out of 10, and then Daniel, 1 out of 10. So we end up getting 1 out of 10,000. So there's a 1 out of 10,000 chance that they all pick the same. Okay, and remember we did probability. So probability means we have to have fraction, decimal, or percentage. The easiest thing here is probably just fraction. The other way that I've seen students answer this in the past, they did put 1 over 10 to the power of 4. So it's just a one number, and then it's 1 out of a 10, but then 4 of them have to pick. So it's 1 over 10 to the power of 4, which gives you the same answer. Okay, number 2. 4 students, 1 from each grades 9 through 12, line up to pose for a photograph. What is the probability that they will be in order of their grades? So just wrote, I should have used this for the top as well. So again, probability. So on the numerator, it's the number of ways it occurs, and then at the bottom is how many ways in total. Okay, question?
Are you using this formula for this question?
So just to say that, so just the probability, I could have used it here. This would be probability of A times probability of B times the probability of C times probability of D. I should have wrote it there, but I didn't. But it's, since we're probability, it's always going to be this one. The other one is when it has a T at the bottom, but we're still doing the same process, but the T is for trials. But S is the total outcomes. Okay, so N at A is how many ways can it occur over the total number of ways it can occur. Okay, so I grab a student from each of the grades, 9, 10, 11, 12, and I want to put them in order. Okay, how many ways can they be in order in order of their grades from 9 through 12? It's not a trick question. How many ways can they be in order? What? Just one way. There's only one way they can be in order, and that's if they're in order. Okay, it's only one way. So we only have one possible way they could be in order, and that's 9, 10, 11, 12. In the order of their grades, only one possible way. Now we want the total number of possibilities. The total number of possibilities. So I'll break it down like this. For the total number of possibilities. 4 students, one from each grade, and they're in a line. Okay, they're in a line. So anytime it's in a line, it's automatic, you should be thinking factorials. Okay, anytime it's a line or a row, it should be factorials, but I'll show you. So I have 4 students. I randomly pick one of them. Okay, wait, sorry, rewind. I can pick any student to line up first. So how many options do I have? How many options do I have for the first?
4.
I have 4. Thanks, Sabrina. So 4. Once I put someone in the first spot, let's use this row. I put one person here. Okay, my next spot, how many people do I have left? 3. Okay, 3, and then after that, 2, and then 1. So that's the total number of ways. That's going to be the denominator. How do I simplify this? 4 factorial. Good. So 4 factorial. So it's one way to be in order, and in the bottom, since it's in a line, it's going to be always that number factorial. So 4 factorial. Okay, which gives us 1 over 24. Okay, you can leave that as that. Or you can convert to decimal or percentage. Okay, Kate selects 4 cards from a standard deck with no replacement. Okay, that means she doesn't. I'm gonna show you one way first. I'm not gonna do this one first. Let's do this one. Let's leap over. Okay, so we wanna know how many chances, or what's the probability that she selects 4 aces in a row. Okay, so I have a standard deck of cards here. So I have a standard deck. She's gonna take out 1 card. What is the chances that she will pick an ace? What is the probability? This is the first trial, so she's gonna take 1 card from here. What is the chances that it'll be an ace? Sophia, your hands up or no? 4 to 52, good. So she has a 4 out of 52 chance to pick an ace here, okay? If you want to put the reduced one, you can, so it's 1 out of 13. But let's just work with 4 out of 52. Okay, so she picks an ace. She gets it. Perfect. Okay, so she takes it out. She doesn't put it back. Say no replacement. Okay, so she doesn't put it back into the deck. Now she's gonna reach in and pick another card out. What is the chances that it's gonna be an ace again? 3 over 51. Yes. So 3 out of 51 because we didn't put that card back. Okay, so we have another one. Oh, she's 2 for 2. Beautiful. She gets another ace. Then once again, since we want, oh, it's 4 aces. Okay, so next one picks in again, hits another ace. Beautiful. What's the chance of that one? 2 out of 50. Okay, and now give me the last one. 1 out of 49. Okay, and I'm going to show you to do it a shorter way. So there's 4 trials, so 4 picks. So that means there's 4 events. So first event, second, third, and fourth. Right? And this is a dependent event, right? Because one affects the next one. So we get, that'll be 24 over, do I have it here? No, I don't. Some monster number. Okay, remember you have a fraction button on your calculator that could reduce for you? And when you reduce it, you get 1 over 270,725. Okay, so a key thing here says order is important. Okay, that's going to distinguish whether we use permutations or combinations. So for this one, it's permutations, it's the P. Okay, so let's take permutations now. Okay, this is a kind of a longer way to look at it. It's usually an easier way mentally. You guys, most people could think this one out, but let's do it a different way. So we want to do, say we do probability using permutations. So the top is how many ways can you pick 4 aces out of the deck? Okay. Well, so what we do is going to be NPR because there's no replacement. So we have NPR over an NPR. Okay. So let's do for the numerator, we're looking at the aces. And the denominator, we're looking at all of them, okay? So the n represents the total number of what here? Total number of? Aces. Good, so aces. So there's 4 aces, and how many do you want to pick? Do you want to pick? All 4. So the numerator becomes 4p4. Okay, 4 aces, picking all 4. So 4p4. You can think as P being picking. So 4 aces, and I'm picking 4 of them. now the denominator is everything together. So numerator is what we're just looking at, which is aces. Now the denominator is everything together. Okay, so now we're looking at the whole deck of cards, the whole deck here. So what's my total in the deck? 52. We have 52. And how many cards are we picking in total? 4. So these two are exactly the same. This and this are, if you expand this, you get 4, 3, 2, 1. If you were to expand this, you get 52, 51, 52. 52 times 51 times 50 times 49. That's what this is. Okay, so then when you plug that into your calculator, it'll get you right to the answer. I really want you guys to understand this way, because when we get to the next chapter, this chapter, next chapter, and the one after, it's all these. So again, the numerator is what you're looking at. In this case, the aces. And then the denominator is everything. Okay. Okay, now what is the probability that she selects 1 heart and 3 spades? Okay, so she's still picking 4 cards, but we want 1 heart and 3 spades. Okay, so let's do this one. I'm just going to show you. I'm not going to separate it. Separate it. Try to think out what I want to show you. Okay, I'm going to do the longer way first. So probably have A and a B. No, that doesn't work. Okay, so I'm going to show you. So we want 2 things to occur in this one. So we want the 1 heart and 3 spades. This is always going to happen for when we do cards. We have the end here, once again. So that's why we're multiplying. Okay, so let's look at the first thing. So, she wants to select first a heart. Okay, so if I went in here and I'm picking out a heart, what is the probability that I will pick a heart? So probability, reaching here and picking out a heart. Yep. Not just 1. How many hearts are there? 13. Okay, so it's 13 out of 52. But that's probability. That's probability. We're looking at the number of ways. Okay, so the number of ways you can just pick hearts. Now rewind. No probability. 1 out of 13 those are probabilities, right? We're looking at just the number of ways. So how many hearts do we have in total? 13. Okay, so I have 13 hearts. And how many do I want to pick? Sabrina? 1. So 13, pick 1. If it was just 1 heart, let's see how many ways we can pick 1 heart. It'd be 13 out of 52. I don't know why I asked that the first time. Sorry. I led you the wrong way. So the number of ways. So the number of ways of just hearts first. So I should have put here H maybe, and then this one will be spades. SP for spades. is how you're gonna do all the card questions when they ask you for multiple things. So always do it this way. Okay, now we want 3 spades. Okay, so how many spades do we have in total? 13. Okay, we have 13 spades in total. And we want to pick how many? 3. Okay, now we're going to look at the total number of ways this can occur. The total number of ways. So when we're looking at the total, we're looking at the whole deck. Okay, so how many cards do we have in the deck? 52. And we want to pick how many in total? 4. Okay, so we're going to plug this into a calculator. By the way, anytime it's 13p with a 1, it's 13. The answer is 13. So 13p1 is 13, by the way. So you end up getting 143 over 41,650. I'm going to show you the other way as well. Now I'm just going to show you this way as well, the longer way. So if you think about it, if I'm picking 1 heart, okay, so what are my options for hearts? Well, I have 13 hearts out of 52. Okay, so 13 hearts over 52. Okay, once I pick a heart, I don't want any more. So now I'm going on to spades. So 13 out of 52 for hearts. Then spades. Okay, how many spades are in the deck? 13, okay? But I took 1 heart out already. Okay, so what am I left with as my total? 51. Okay, then we keep going. So again, this was the 1 spade. So we had a 13 out of 52 chance to pick out a heart. We took that heart out. Now we're picking spades. So we have 13 out of 51 chance to pick a spade. Okay, now we want another spade. So what's my next fraction going to be? Sorry? 12 over 50, good. So I took 1 of the spades out. Okay, so that leaves 12 spades, and now we have 50 cards left. And then my last one is 11 out of 50. Sorry, 11 out of 49. Okay, so the 52p4 is this same thing. Okay, but then this changes the top because first we're picking a heart, and then we're picking 3 spades. Okay, so that's another way to look at it. So 13p1 is just 13, and 13p3 is the same thing as 13 times 12 times 11. All right, last question. This one's tricky. gonna put it to 26 because that's how many we have in our classroom. I wanna find out what's the probability that none of you guys have the same birthday. You'd be very surprised at the percentage. I was surprised when I did this the first time. So I'm gonna change it to 26. Which way do you want me to do first? The one with all the fractions or the P? Hmm?
You do the PH one.
Wanna do the P one first? Okay, so we're on the probability that nobody shares the same birthday. Okay, so we're looking at the number of ways for the birthdays, again, over the total number of ways. Okay, so the number of ways that it can occur. Okay, so we're looking at individual birthdays. So how many birthdays can there be so we're looking at number of ways for birthdays. How many ways can it happen? How many options are there for birthdays? 365, right? So there's 365 birthdays. Okay? How many different ones do we want? 26. So we want 26 different ones from the 365. Okay, that almost looks like that should be the denominator, okay, but the denominator is different. So every time you have a birthday, the denominator never changes. So I'm gonna tell you what this is and I'll explain it after. So the bottom is gonna be 365 to the power of 26. And I'll show you with the fraction.
Why though?
I'm gonna show you with the fractions and it'll make sense. I don't know what this equals. 365 P26 equals divided by 65 power of 26 and 0.4. So there's a 40% chance that none of you guys share the same birthday from both cohorts. This classroom has 26 in total. So 40%. Isn't that amazing? That means 60% of you, there's a 60% chance that two of you guys share the same birthday. And I'm gonna go through my birthday list and we'll see if anyone matches. Okay, so this is how you look at it. Okay, so let's say we go with Logan first, okay? So how many birthdays out of how many can he have? Say he doesn't have a birthday, we're just gonna give him a random one. How many options do you have? I said, Logan, you can pick your own birthday. Which one do you want? You have how many, so don't answer that. How many choices do you have? How many choices do you have?
One has 365 days.
You only have one option?
I don't have one option.
Sorry?
You said I only have one option.
You can pick a birthday. But out of how many options do you have?
365.
365 options. You have 365 options out of 365. So the number of options you have is 365 out of 365, okay? But now we want done, yes?
What if it's a leap year?
Where does it are in leap year?
I don't know.
Okay? But just do 365 as the standard, okay? Okay, so he picks a birthday, then I said, Jake, you can have another birthday, but you can't pick his. Okay, you can make up your own. Okay, how many options does he have? 364. But we don't decrease the denominator. We can't decrease both of them. So we just say he has one less option now out of the 365 days. Okay, so Jake picks his, and it's Kate, is it? That's right. I don't have my seating plan here. So Logan picked, Jake picked, now Kate. Then now you have an option. You can pick your own birthday. How many options do you have? Well, she doesn't have, these two are gone. She can't pick the same one because we want all different. So then she's at 363 out of 365. Okay? This keeps going. So that's the same thing here. So 365, you're picking 26 different birthdays. Okay, so 365, pick 26. The denominator doesn't change. So this fraction is gonna happen 26 times, and my denominator stays the same every single time. Okay? So that's why it's 365 to the power of 26. And my denominator is not gonna change. Because the calendar, it doesn't change, it's 365 regardless. Okay, we keep going. So that's the long version of this. I kind of gave out the answer for the second part. So if 40% do not have a birthday, 40% chance that any of you guys share the same birthday, what is the probability that at least two of you guys do? Don't think too hard.
60%.
Perfect, 60%. So 100, so if none is 40%, then the opposite would be at least two. At least two share the same birthday. So 100 minus 40 equals 60%. I found that pretty amazing that in one classroom, it's a 60% chance that two of you guys share the same birthday. So let's look at my list. See if it's true. It's usually it ends up two have the same birthday. Here, two. Haley and John. July 24th, same birthday. Actually, John's no longer in this class. Morano. So that wouldn't work, that would have been 0. My advanced functions class, I have two people that have the 21st, Nora and Alessia, and I have two people that have the August 25th, Vincent and Alyssa. I think that's pretty amazing. I thought it would be such a low percent for two people to share the same birthday. Okay, so that's the end of the lesson. Homework is there. So page 93, 1 to 9, 11, 13, 14A. Did I not put the review there? Okay, so you got the whole period. So you got an hour and a half. You should be finished this one, I don't know, half hour. And then review. Page 96. I'll write this out on e-learning as well. So I'll type it out on the announcements page. Let's see, 4 to 9. When I told the other class, we have the tests. You guys will have a different one than cohort B. Like, I probably won't make any question the same, but they'll be different. But 95% of my questions are right from the homework. Okay, yes.
Is your